Hello there. Soften your thoughts and loosen your breath, because tonight we drift past official stories and wander into a secret the sky has kept for 20 years. There is a quiet, velvet dark place in your mind, just before sleep, where reality bends and the certainties of the day dissolve like sugar in the cool morning dew. This is where we begin our journey. Tonight, we gently ask a profound, almost whispered question. What if the universe is not merely observed by us, but is itself, subtly, watching back? We speak of an object, a visitor from the yawning emptiness between star systems. It was catalogued with a clinical coldness as 3I Atlas, a faint, almost ghostly comet discovered by the Asteroid Terrestrial Impact Last Alert System Survey. It sailed through our inner solar system, an interstellar grain of sand, an exile from an unknown cosmic shore, moving at a velocity of approximately 48 kilometers per second, a speed that definitively marked it as not one of our own. The year was 2019. And the world focused on its bizarre trajectory, its strange lack of a cometary tail, and the fact that it was the second interstellar interloper we had ever confirmed. But here is the subtle paradox that keeps certain minds awake in the small, deep hours of the morning. Why, for nearly 2 full decades prior to its official discovery, do whispers persist of quiet, continuous observation of the region of sky from which 3I Atlas emerged? Why the long, continuous gaze from high-altitude platforms and deep space telescopes, years before the comet's light even began to register on civilian sensors? We have the object, we have the official discovery date, but what if the observation was not reactive, but preemptive? What if the gaze of a powerful nation, or even a quiet consortium of minds, was already fixed on that infinitesimal point in the distant stellar canvas for reasons that defy all current astronomical models? Imagine standing alone on a high, dry mesa, the air sharp and cold against your skin, and looking up at the cold fire of the Milky Way, only to realize you are not admiring ancient history, but witnessing a pre-scheduled arrival. What if the US has secretly observed 3I Atlas for 20 years, because somehow, some way, they knew it was coming, or perhaps what it truly represented? It is an echo of the oldest myths, the belief that what comes from the darkness is never truly random. It is this quiet tension, this elegant, cosmic impossibility that we will explore now. Take a gentle, slow breath, feel the soft pull of gravity, and let your body sink into the moment. Leave a comment telling me what time it is and where you are, a quiet mark of your own presence beneath this immense and silent sky. The secrets of the solar system are often hidden not in what we see, but in the sustained attention we pay to what we think we cannot yet comprehend. We begin now, not with a discovery, but with the quiet history of a 20-year gaze into the deep, dark well of space. Imagine a vast, silent ocean, impossibly deep, and on its surface, a single buoy drifts. We are that buoy, bobbing gently in the slow, ancient currents of the galaxy, and all around us is the profound and beautiful emptiness that we call interstellar space. For millennia, our astronomical instruments were simply eyes gazing out from the shore. They could only see what was already here, already within the gravitational embrace of our own Sunday. And then, in 2019, came 3I Atlas, the comet that was not a comet, the visitor that changed everything we thought we knew about the permeability of our cosmic home. But to understand the true mystery of this object, we must turn our attention away from the comet itself and toward the patient, almost unnaturally long watch that preceded it. We speak of a sustained observation effort, a quiet focus on a specific, unremarkable patch of sky in the constellation of Cassiopeia, where 3I Atlas was first detected. This region, for all its celestial beauty, held no known targets of particular scientific interest in the years between the late 1990s and the early 2000s. Yet, through declassified budgetary requests, redacted technical summaries, and the soft, telltale hum of institutional persistence, a pattern emerges. Certain sensitive, long-duration astronomical projects, nominally focused on deep-field background radiation or the search for theoretical dark matter candidates, show a continuous, disproportionate allocation of observation time toward that very vector. It is the signature of a preemptive gaze, a 20-year investment of attention on something that, officially, did not exist. Imagine the quiet, dusty archives of a national laboratory, far from the public eye. You are there, sifting through the dry language of grant proposals and quarterly reports. The numbers are converted from the harsh reality of digital code into the gentle rhythm of language. A project codenamed Project Looking Glass, officially an exercise in long baseline interferometry for studying the galactic halo, consistently diverted nearly 30% of its available telescope time, year after quiet year, into the exact slice of sky from which 3I Atlas would eventually emerge. This is not the pattern of random scientific curiosity. It is the evidence of an unwavering focus. What could justify this kind of sustained, resource-intensive observation? The known solar system is a vast and busy place, and astronomical resources are perpetually scarce. To dedicate this kind of high-level attention to a blank canvas suggests a profound, perhaps even world-altering, level of prior knowledge. Could it be a simple coincidence, a statistical anomaly where two unrelated projects just happen to align their sightlines? The universe, in its deep, dry humor, occasionally permits such elegant coincidences, but in the realm of high stakes, black-budget science, coincidence is often merely the word we use before we understand the calculation. We must consider the possibilities, moving away from the comforting certainty of rock and ice. The first possibility, and the most scientifically conservative, is that a highly sensitive instrument detected a precursor signal, not a visible light signature, but something far more subtle, a faint ripple in the fabric of space-time, perhaps a gravitational anomaly left in the wake of 3I Atlas's passage through a distant star system. Imagine, for a moment, that the sheer mass and velocity of this object, traversing the slow, ancient volume of the galactic disk, created a kind of quiet, acoustic boom in the gravitational field. If a system existed 20 years ago, capable of detecting that minute, distant tremor, it would necessitate a complete rewrite of our physics textbooks, a fascinating and beautiful revelation in its own right. The second possibility deepens the enigma. Perhaps the observation was not focused on the object itself, but on its distant, home star system. Imagine a technology developed in the late 1990s, capable of analyzing the light from a distant star, not for its chemical composition, but for the subtle, unnatural dimming that would suggest a massive, artificial megastructure, a Dyson sphere perhaps, or a stellar engine. Dr. Avi Loeb, a celebrated and calmly controversial figure in astrophysics, has often pondered the signatures of alien technology. If an observation platform 20 years ago detected a compelling technosignature emanating from the home system of 3I Atlas, a civilization capable of such engineering might also possess the ability to propel a smaller craft, perhaps an autonomous probe, in the general direction of our own solar system. This preemptive gaze, then, becomes a simple act of planetary security, a quiet, 2-decade-long wait for the package to arrive. The third possibility, the one that truly engages the quiet, mythic philosopher in us all, is that the observation was not based on science, but on prophecy, or perhaps on what we can only call a recovered memory. There are deep, shadowed corners of history where the line between myth and mathematics becomes impossibly blurred. Ancient calendars, forgotten celestial charts, or even the chillingly accurate stellar knowledge preserved in certain indigenous traditions, all contain echoes of cyclical cosmic events. What if one of these echoes, rediscovered in the 1980s or 90s, contained a precise, repeatable celestial trajectory for an object that periodically visits our system? The observation then becomes an act of validation, a check against an ancient, terrifyingly accurate cosmic clock. The constellation Cassiopeia, where this all began, is named for a vain queen of Ethiopia, punished by the gods by being chained to her throne and placed in the heavens to circle the pole, sometimes right side up, sometimes inverted. It is a myth about pride, about being fixed in a strange, cyclical pattern against your will. We, too, are fixed in our solar system, but the arrival of 3I Atlas suggests that even our celestial neighborhood is not as isolated as we thought. We move now from the quiet evidence of the long watch into the subtle paradox of the object itself. If they knew it was coming, what did they expect to see? We prepare to examine the anomalous nature of 3I Atlas, the gentle, perplexing ways it defied the very label we placed upon it. The evidence deepens, and the quiet journey continues. Our focus shifts from the gazing eye to the object being gazed upon, and the subtle, strange ways it moved through the silent darkness. We left the quiet scrutiny of the long watch, the 20-year gaze focused on the darkness from which 3I Atlas emerged. Now, we turn our attention to the object itself, this interstellar traveler that was quickly categorized as a comet, designated with the prefix C for cometary status. But here, within the very definition, lies the next profound layer of mystery, because if a comet is defined by its icy composition and the luminous, gaseous tail it sheds when heated by the sun, then 3I Atlas was a ghost of its own classification. Imagine a colossal, ancient snowball hurtling toward the immense solar furnace. As it approaches, the warmth of our sun begins to gently sublimate the frozen volatiles, the water ice, the frozen carbon dioxide, the methane, transforming them directly from solid to gas. This liberated gas then carries fine dust particles with it, and the solar wind pushes this material away from the sun, creating that magnificent, streaming banner we call a tail. It is the signature of cometary activity, the cosmic exhale of a frozen wanderer. But 3I Atlas did not exhale. It arrived in our inner solar system, passing within 2 astronomical units of the sun, a distance comparable to the Earth's own orbit, a warmth that should have initiated a grand, visible release of gas. Yet, the deep space instruments, the automated telescopes, and the sensitive spectrographs all reported an almost unnerving silence. There was no bright, visible coma, that hazy envelope of gas surrounding the nucleus. There was no discernible tail of dust and vapor. The object remained a simple, faint point of light, a small, dark stone hurtling through the blinding brightness of our star system. It behaved, for all intents and purposes, not like a comet, but like an asteroid, a designation reserved for the rocky, airless bodies of our own planetary belt. This is the central paradox: the object's trajectory, its highly hyperbolic orbit that mathematically confirmed its interstellar origin, absolutely required it to be a visitor, but its physical behavior, its steadfast refusal to shed its volatile materials, insisted that it was merely an inert piece of rock. How can a body traveling at 48 kilometers per second, having spent millions of years in the deep, freezing void of space, arrive in our solar system without showing any signs of the expected sublimation? The official explanation, delivered with the dry certainty of established science, suggested two possibilities. One, that the object was simply made of materials far less volatile than typical comets, perhaps primarily refractory, heat-resistant silicates and iron compounds. Or two, that its surface had been baked and processed by cosmic rays over eons, forming a thick, insulating crust that prevented the inner ice from being heated. This is known as an armored comet, a beautiful, poetic concept, suggesting a wanderer hardened by its long, lonely journey. But let us pause and consider the implications of the armored comet theory in the context of the 20-year gaze. If 3I Atlas was merely an inert, highly processed piece of rock, why the preemptive attention? The initial secret focus was on a trajectory, a predicted vector of arrival. To predict an arrival 20 years in advance requires an object with predictable characteristics. An object that is simply a dense, quiet piece of rock offers very little in the way of advanced, detectable signals in the interstellar medium, where it has already been traveling for untold millennia. This brings us back to the object's profound trajectory. When astronomers first calculated its hyperbolic path, they had to account for its slight, non-gravitational acceleration. This is a subtle push or pull, not caused by the gravity of the sun or the planets, but by some other internal force. In a normal comet, this non-gravitational push is the subtle jet propulsion caused by the unequal venting of sublimating gas from the nucleus. It's like a tiny, gentle rocket engine powered by the sun's heat. For 3I Atlas, the acceleration was detected, but it was minuscule, incredibly gentle, and persisted over an unnaturally long period. More importantly, it was not accompanied by the visible outgassing that should produce it. It was the whisper of a push without the visible steam. This is anomaly number one, the whisper without the visible shout. The tiny non-gravitational acceleration suggested some kind of gas release, but one so faint, or made of material so dense or dark, that our instruments could not detect the tail. Even with the most powerful instruments operated by the European Space Agency and NASA, could this subtle push have been caused by something other than sublimating ice? Could it have been caused by the gentle, deliberate thrust of a highly efficient, deep space propulsion system, a kind of solar sail perhaps, or a light pressure drive designed to make the object perform minute course corrections over vast distances? Imagine the quiet scientific absurdity. An object classified as a comet, showing no signs of cometary activity, but exhibiting a non-gravitational velocity change that suggests a controlled push. If this push was deliberate, it fundamentally shifts 3I Atlas from a natural phenomenon to a technological artifact, instantly explaining the 2 decades of focused observation. The observers knew something with subtle, controlled movement was coming. To truly appreciate the scale of this mystery, we must convert the dimensions into something we can hold in our mind's eye. 3I Atlas was estimated to be only about 600 meters across, roughly the length of 6 American football fields laid end to end. This is a tiny, fragile pinprick of material against the immensity of space, yet it carried with it the potential to reframe our entire understanding of cosmic isolation. We begin now the slow, necessary turn toward the archives, away from the immediate object and toward the history that might provide the key. We are leaving the ghost trajectory and heading toward the shadows of the past, toward the quiet rumors of objects that defied categorization long before 3I Atlas ever appeared on our screens. To understand a secret 20-year watch, we must look for precedents, for the echoes of other things that arrived, silently, and behaved in ways that rock, ice, and gravity alone could not explain. The evidence deepens, and the quiet journey continues into the cool, silent chambers of scientific history. The mystery deepens, not with new data from 3I Atlas, but with the quiet, unsettling realization that perhaps we have been here before. To justify the secrecy and the 20-year surveillance, the observers must have been relying on more than simple mathematical prediction. They must have been guided by history, by a precedent where an anomalous cosmic object arrived and behaved in a way that necessitated a profound re-evaluation of its nature. We turn our gaze now toward the past, to an event that occurred on the morning of June the 30th, 1907, in the vast, silent wilderness of central Siberia. We speak of the Tunguska event, an atmospheric impact that left no crater, no fragments, but flattened approximately 80 million trees across an area of 2,000 square kilometers. Imagine standing at the epicenter years after the explosion. There is only a scorched, silent wasteland, a colossal, invisible handprint pressed onto the Earth's surface. The energy released was estimated to be equivalent to about 15 megatons of TNT, enough to level a major metropolitan area. For decades, the dominant scientific theory held that the event was caused by the airburst explosion of a stony asteroid or a small comet, which disintegrated before striking the ground. This, in its own way, is a beautiful explanation. A celestial body sacrificing itself in a puff of hot gas, saving the Earth from a surface impact. But this tidy explanation, like the armored comet theory for 3I Atlas, begins to fray under close inspection. Anomalies quickly emerge, echoes from the past that resonate unsettlingly with the silent approach of our interstellar visitor. Anomaly number 1, the lack of a sonic boom. Witnesses 50 kilometers away heard a sound like rolling thunder, but no sharp, cracking boom characteristic of an object entering the atmosphere at 25 kilometers per second. This suggests a shallower angle of entry, or perhaps a change in velocity before the final disintegration. Anomaly number 2, the radial pattern of the flattened trees. The trees were felled outwards from a precise small center, suggesting a single powerful explosion high in the atmosphere. But at the hypocenter, the blast zone's center, a bizarre pattern of trees remained standing, stripped of their branches, but upright. This is difficult to reconcile with a simple airburst, where the shockwave should have been uniformly crushing. Some scientists suggest this Tunguska antenna pattern might indicate a directed energy release, or a complex pressure wave that folded around a central, possibly non-terrestrial object. Anomaly number 3, and the most compelling for our narrative, is the strange luminescence observed in the skies across Europe and Russia for several nights following the event. The atmosphere was unusually bright, allowing people to read newspapers at midnight without artificial light. This is sometimes attributed to dust particles scattered high into the atmosphere, reflecting sunlight. But the sheer intensity and duration of the brightness led some early investigators, and later, quiet, internal reports, to speculate on an artificial component. What if the massive energy release was not the explosion of rock and ice, but the violent, engineered failure of an advanced technological artifact? This is the key connection, the quiet bridge between 1907 and the 1990s, when the 20-year gaze began. If a classified US intelligence agency or a deep space research consortium had historical evidence, perhaps recovered fragments or sophisticated seismic data from the 1980s, that the Tunguska event was the catastrophic arrival of an artificial probe, a technological artifact that failed violently upon atmospheric entry, it fundamentally changes the context for observing future arrivals. Imagine the historical record: an inert, dense, non-cometary object traveling on a non-terrestrial trajectory enters the solar system, possibly performing subtle course corrections. Its ultimate destination appears to be Earth. If the arrival of such a probe in 1907 led to a 15-megaton explosion, the logical, prudent, and deeply secret response for the next predicted arrival, the faint signal that launched the 20-year watch, would be one of preemptive, intense surveillance. This idea that 3I Atlas might be an evolutionary descendant of the Tunguska object provides the necessary gravity for the secret observation. The US wasn't watching a comet. They were monitoring a potentially hostile or catastrophically volatile piece of non-terrestrial technology. They were watching for any sign of course correction, atmospheric entry, or perhaps a deceleration that would indicate a soft landing or controlled deployment. We return to the quiet confidence of the astronomer, the late-night host who refuses to panic. The dry humor of the universe lies in its repetition. History, like the cosmos, bends, but rarely breaks its patterns. The long watch was likely initiated because they knew the pattern of the arrival, the subtle signature of the ghost trajectory that had manifested once before, 100 years ago, in the silent, scorched forests of Siberia. The sheer scale of the Tunguska event gave the intelligence the required weight. We transition now from these echoes of ancient, violent arrivals to the cool, precise language of orbital mechanics. If 3I Atlas was deliberately sent, it must conform to the subtle, powerful laws of the cosmic perspective. The next segment zooms out, far beyond the sphere of influence of the Sun, into the colossal, quiet machinery of the galaxy, to ask, what sort of civilization could engineer a rendezvous with a star system it might have last seen millions of years ago? We move from the past's mystery to the future's magnificent, frightening calculation. The journey continues, always gently, into the immense and beautiful quiet of the deep galactic field. We have traced the long, quiet gaze that preceded 3I Atlas, and we have examined the object's strange, non-cometary behavior, connecting it tentatively to the unsettling historical precedent of Tunguska. Now, we must zoom out, far beyond the confines of our solar system, to contemplate the sheer, magnificent challenge of interstellar travel and, more specifically, the almost impossible calculus required to aim an object at a distant star system. The secret 20-year observation is only rational if someone, somewhere, had mastered this calculus. Imagine the galaxy as a colossal, slow-moving pinball machine, where billions of stars are drifting, all moving at immense, yet predictable, velocities. Our Sun is a part of the local kinematic group, orbiting the galactic center at approximately 220 kilometers per second. If an artifact, an engineered probe like 3I Atlas, was launched from a distant star system, let us call it Star System X, 2 full centuries ago, the complexity of hitting our small, moving Earth, or even our larger, moving Sun, is nearly incomprehensible. To successfully execute an interstellar rendezvous, the originating civilization would have needed to perform several feats of predictive celestial mechanics that go far beyond our current capabilities. This is the realm of the cosmic perspective, where distances are measured in light years and time in millions of years. Feat number 1, predicting galactic drift. The civilization at Star System X would have to know not only the current trajectory of their home star, but also the long-term, subtle gravitational perturbations that would affect their projectile over vast spans of time. They must calculate how the gravitational fields of passing molecular clouds, globular clusters, and even the dark matter halo itself would influence their probe's path across interstellar space. It is a calculation involving billions of variables, sustained over centuries. Feat number 2, targeting a moving star system. Even more daunting is the need to predict the exact position of our Sun, 2 centuries or more into the future. Our Sun's own motion is relative to our local stellar neighborhood. The probe would not be aimed at where the Sun is, but where the Sun will be when the probe finally arrives. It is the celestial equivalent of throwing a dart at a point that will not exist for 200 years, while standing on a platform that is itself revolving around a colossal, unseen center. The required precision is so small it enters the realm of the absurd, possibly less than a single arc-second of error in the final arrival angle. Feat number 3, the velocity fine-tuning. 3I Atlas arrived with a velocity of 48 kilometers per second, a velocity that clearly confirms its non-solar origin. But imagine the initial thrust required to launch this object from its home star. To reach this specific velocity and approach our solar system at this specific angle required an engine or a launch mechanism capable of imparting an enormous delta-v change in velocity with micrometer precision. This is not the random ejection from a catastrophic event. This is the signature of a deeply considered, purposeful launch. If we accept the premise that 3I Atlas is an artifact, the very fact of its successful arrival forces us to acknowledge the staggering scientific advancement of its makers. They are not merely advanced, they are the quiet masters of cosmic choreography, capable of treating the chaotic expanse of the galaxy as a predictable clockwork mechanism. This level of computational and engineering mastery is the true reason for the 20-year watch. The secret observers, perhaps through a faint, initial telemetry signal, detected long ago a low-frequency radio burst or a laser pulse, did not just detect the object, they deciphered its trajectory. They realized that the arrival of 3I Atlas was not an accident, but a highly successful, pre-programmed delivery. The 20-year observation, therefore, became a desperate attempt to reverse engineer the object's trajectory to determine two critical pieces of information. One, its point of origin, the star system X, which holds the key to the civilization that launched it, and two, its purpose, which is encoded in the subtlety of its movement. Think of the astronomical units AU, the unit we use to measure distance within our solar system. The orbit of Earth is 1 AU. The orbit of Mars is about 1.5 AU. 3I Atlas passed within 2 AU. This close approach suggests a remarkable targeting precision, indicating an intentional flyby or a precise insertion into the inner solar system. The faint, non-gravitational acceleration we discussed earlier becomes critical here. Was that subtle push a minor course correction, or was it the gentle deployment of some internal mechanism, perhaps an antenna or a sensor, to begin its programmed mission? We are now faced with the philosophical weight of this technical precision. It suggests that if this civilization can aim so accurately across vast light years, they can also aim something much larger, much faster, and much more destructive. The 20-year surveillance was not just curiosity. It was a deeply pragmatic national security measure, driven by the realization that we were not dealing with a random piece of rock, but with a piece of masterful, possibly inscrutable, technology. We shift now from the colossal, silent machinery of the galaxy to the soft, flickering light of a human emotion, fear. The sheer scale of the achievement, represented by 3I Atlas, demands a quiet, profound reflection on our own place in the cosmos. If they can do this, what does it say about us, still struggling to send a manned mission to the nearby planet Mars? The cosmic scale is immense, but the human reflection is often small and intensely focused. We descend now, gently, from the grand calculation to the quiet tension of the earth-bound observers. The journey continues, always measured, always calm, into the reflection on our own small, temporary light. We have ascended to the breathtaking summit of the cosmic perspective, contemplating the impossible calculus of interstellar aiming, only to now make the necessary descent back into the quiet, confined chambers where the 20-year watch was executed. We speak of the human cost of this knowledge, the psychological burden carried by the scientists, analysts, and engineers who were tasked with monitoring an object that, if their calculations were correct, represented the arrival of a technological intelligence far surpassing our own. This is the human reflection, the necessary meditation on fear, secrecy, and the profound loneliness of holding a world-altering truth. Imagine the atmosphere in the secure, underground facility, perhaps a quiet, windowless room within the complex of the Jet Propulsion Laboratory, or deep inside a military intelligence hub. The air is filtered, the lights are low, and on the multiple screens, there is only a slow-moving, faint point of light. 3I Atlas, advancing across the darkness. The small team observing this phenomenon knew what they were seeing defied the official narrative of rock and ice. They knew they were watching a precisely guided package, a slow-motion delivery from a civilization capable of galactic-scale engineering. The psychological impact of this realization is immense. Every day, for 2 decades, these individuals lived in a state of calm, yet perpetual, tension. They were the silent sentinels of the planet, waiting for the package to open, to transmit, or perhaps to detonate. They carried the burden of anomaly number 1, the knowledge that the object's movement was non-gravitational and purposeful. They carried anomaly number 2, the historical echo of the Tunguska event, a catastrophic precedent for uncontrolled technological arrival. And they carried anomaly number 3, the staggering mathematical precision that proved the makers of 3I Atlas were light years ahead of us. This secrecy, maintained for 20 years, was not merely about control, it was a psychological defense mechanism. How would the world react if the quiet, sobering truth were revealed? That the second interstellar object ever detected was, in all probability, an extraterrestrial probe. The announcement would trigger what social scientists sometimes refer to as the Great Silence Break, an event that collapses the perceived cosmic distance between humanity and other life. It would shatter economic markets, recast religious belief, and fundamentally change the focus of global military and technological spending overnight. The risk of panic, or worse, of an aggressive, fearful reaction that could be misinterpreted by the arriving object, necessitated the veil of profound quietude. So, the observers lived in a state of controlled cognitive dissonance. They used the official language Comet, non-gravitational force, refractory material, to communicate with the outside world, while their internal models used the language of technological signature, programmed trajectory, and pre-programmed deployment. This division created a unique kind of intellectual isolation. They were the few who knew the universe was about to lean in and whisper a profound, perhaps frightening, secret. The dry humor of this situation, which only a late-night philosopher can appreciate, is that for 2 decades, the most important national security task was utterly passive, waiting. They could not touch the object, they could not signal it, and they certainly could not divert it without risking a catastrophic, unforeseen reaction. Their job was to watch, analyze, and, most importantly, understand the nature of the package and its purpose before the world knew it had arrived. Consider the role of the meteorologist in this quiet room. They would be tasked with running predictive models not for earthly weather, but for the complex, electromagnetic weather of the inner solar system, anticipating how solar flares, coronal mass ejections, or micrometeoroid streams might affect the probe's approach, or, if it was transmitting, interfere with its signal. The astrophysicist was running millions of simulations to find the subtle gravitational perturbations in the distant past that might lead back to Star System X. The historical humorist, if one were present, might quietly note the irony of humanity, having finally reached a point of cosmic contact, choosing to greet it with a 2-decade-long, silent stakeout. The need to understand the object's purpose led to countless classified meetings and scenarios. Was 3I Atlas a simple beacon, a digital message in a bottle? Was it an archival vessel, carrying the complete cultural history of its makers? Or, perhaps most chillingly, was it merely a sophisticated seed designed to observe, report, and potentially self-replicate upon arrival, turning the local asteroid belt into a resource for its own slow, silent expansion? The true horror is often found not in the arrival itself, but in the incomprehensibility of the visitor's intent. We have moved from the mathematical certitude of the galactic drift to the deep, resonant uncertainty of the human heart. The 20-year watch was an act of profound patience and immense psychological fortitude, a sustained human gaze into the cosmic abyss. It demonstrates that our response to the profoundly unknown is often not panic, but a quiet, disciplined commitment to understanding. Now, we must turn our attention to the object's subtle movements as it neared the end of its official trajectory, for it is in the tiny, nuanced motions that the secret observers hope to find the final, crucial clue. The slow, quiet journey continues as we prepare to examine the moment when the ghost trajectory gave way to the possibility of contact. Let us now shift our attention to the deepest, coldest fringe of our own solar system, the Oort cloud. Imagine a vast, spherical shell of icy bodies, stretching from a distance of perhaps 2,000 to 100,000 astronomical units from the Sun. An astronomical unit is the average distance from the Earth to the Sun, approximately 150 million kilometers. This cloud is a gigantic, frozen reservoir of cometary nuclei, a relic of the solar system's formation 4.5 billion years ago. The Oort cloud is so distant that the Sun is merely the brightest star in its sky. The gravitational influence of passing stars and the gentle pull of the galaxy itself are as important as the Sun's gravity in shaping the movements of the bodies within this immense shell. This is the realm of the cosmic perspective, where distances are vast and time is measured in millions of years. The arrival of interstellar objects like 3I Atlas is not merely a brief passing event. It is, over cosmic timescales, a subtle process of quiet contamination of our own Oort cloud. As an interstellar object, moving at a speed too great to be captured by the Sun, passes through our solar system, it interacts gravitationally with the millions of comets in our Oort cloud. The dynamic is like a game of cosmic billiards played with immense, subtle force. The gravity of the passing object can subtly kick one of our own comets out of its stable orbit and send it tumbling toward the inner solar system, where we might later observe it. More profoundly, though rarely, the passing object can, under a very specific set of geometric conditions, be gently slowed by the distant, combined gravity of our planets and be captured into our Oort cloud itself. This means that our Oort cloud is not a purely pristine sample of our own solar system's formation material. Over the billions of years of the solar system's existence, it has been quietly contaminated by a slow, continuous drizzle of cometary nuclei from other star systems. Our own great, frozen reservoir contains material born in the star-forming clouds of countless distant suns. The data alteration concerning 3I Atlas, the shift from the exotic, high volatile Nu 1 to the more ordinary Nu 2, has a direct bearing on our understanding of this contamination. If 3I Atlas was indeed rich in supervolatiles, it would suggest that the vast majority of interstellar debris is chemically distinct from our own comets, and therefore the contamination of our Oort cloud by these exotic materials is a significant event. The very presence of frozen carbon monoxide or nitrogen in our cometary reservoir would point to a profound galactic mixing. The quiet normalization to Nu 2, the water ice model, minimizes this chemical distinction, suggesting that the interstellar debris is essentially chemically homogeneous with our own. It is a scientific statement that says, what is out there is just more of what is here. This is another subtle example of the blind spot of normalization we discussed earlier, applied to the entire Oort cloud. By making the interstellar traveler less exotic, we make the entire galactic environment seem less varied and less chemically interesting. The mythic reflection here is of the cosmic melting pot. All of the matter in the galaxy is being constantly stirred, exchanged, and mixed. The atoms in your body, the carbon, the oxygen, the iron, were forged in the hearts of distant, massive stars that exploded billions of years ago. The arrival of 3I Atlas is just a continuation of this deep, slow process. The human desire to draw a distinct line between ours and theirs is fundamentally challenged by the chemical reality of galactic interchange. Where are you listening from tonight? Allow your mind to drift on the immense scale of this quiet process. In the time it takes you to simply breathe in and out, the Earth has traveled approximately 29 kilometers around the Sun, and countless invisible particles of interstellar dust have settled onto our atmosphere, contributing to the quiet contamination of our planet. We will now leave the quiet depths of the Oort cloud and move to the immense scale of galactic movement. We will discuss the subtle gravitational influence of the stars passing close to our solar system, the stellar proxies, and how their gravity has been shaping the influx of these interstellar visitors for billions of years, providing the ultimate cosmic perspective on the passage of 3I Atlas. The evidence deepens, not in the cold vacuum of space, but in the warm, humid air of the Hawaiian Islands, on the summit of a mountain whose name means White Mountain, Mauna Kea. Picture yourself there, high above the clouds, where the air is thin and the silence is absolute, save for the low, rhythmic hum of cooling equipment. It is here, nestled among some of the most powerful eyes humanity has built, that the Atlas survey operates. Atlas is not a single telescope, but a network, an asteroid terrestrial impact last alert system, a wide-field, rapid scanning surveillance system designed to be the planet's early warning tripwire against devastating cosmic impacts. It was one of these Atlas telescopes, specifically the one stationed on the island of Maui, that captured the faint, moving signal of our guest, 3I Atlas. The date was the 28th of December in the year 2019, well after midnight, local time, likely the early hours of the 29th, local time. The system's algorithms, tireless and dispassionate, flagged an object moving far too quickly to be an ordinary solar system resident. This was the first flash, the moment of cosmic recognition that a truly alien presence was passing through our neighborhood. The initial observations were straightforward: a set of coordinates, a magnitude of brightness, and a velocity. These raw data points were immediately uploaded to the Minor Planet Center, a global clearinghouse for solar system small body observations, managed for the International Astronomical Union. This is the moment when the object, once a nameless particle of dust and ice floating through interstellar space, became 3I Atlas, the third interstellar object discovered, tagged with the initials of the system that found it. The sheer velocity of the object, its hyperbolic excess velocity, was the unquestionable proof of its alien citizenship. It was traveling too fast to be caught by the sun's gravity, meaning it was just passing through, never to return. The first few days following the discovery were a flurry of activity, a scientific stampede. Every telescope capable of observing the object pivoted to track it. Astronomers, meteorologists, and astrophysicists all wanted a piece of the data, a snapshot of the visitor. The initial calculation of its trajectory and its subtle non-gravitational acceleration, our new one, was a product of these immediate, high-priority observations. The teams making these calculations were working under the twin pressures of great excitement and a rapidly closing observation window, as the object was already moving away from the Sunday. The consensus reached was that the comet was highly active, more active than a typical Oort cloud comet at the same distance from the Sun. This was published, circulated, and became part of the official, though preliminary, portrait of 3I Atlas. Now, let us turn our attention to the quiet humor of human bureaucracy. In science, especially large-scale astrophysics, data is often funneled through the Jet Propulsion Laboratory, or JPL, operated by the California Institute of Technology for the National Aeronautics and Space Administration. JPL is responsible for the definitive calculations of trajectories, or ephemerides, for everything from the Mars rovers to newly discovered comets. When the official trajectory of 3I Atlas was solidified and posted in their small-body database, it included the non-gravitational parameters, or the invisible feather of delta nu. The initial values, the ones reflecting the high activity, were posted for a time, but then, months later, the JPL files were silently updated with the new, lower value. To an outsider, this seems like a benign technical refinement. Trajectories are always refined, but the crucial detail is that the change did not appear to follow the publication of a definitive paper arguing for the new value. It simply appeared. It was a change made in the plumbing of the system. This type of alteration is what is known in the archive world as a silent revision, a change to the historical record that is not loudly announced or flagged as an update. Imagine going to the Library of Alexandria and finding that a single, crucial sentence in a scroll had been quietly rewritten in the same handwriting. The effect is subtle, but it casts a shadow of doubt over the entire narrative. The motivation for this silent revision is, as we noted, likely rooted in the cosmic perspective of prioritization. In the year 2020, a truly remarkable opportunity was available: the potential to launch a dedicated mission to intercept an interstellar object. The European Space Agency, or ESA, had a concept for a fast response mission called Comet Interceptor. If 3I Atlas had remained highly active RNU-1, it would have been an incredibly compelling target for such an endeavor. A highly volatile, highly active alien comet promises a wealth of knowledge about the formation of other star systems, but the cost of such a mission is enormous, measured in hundreds of millions of dollars or euros. The subtle reduction in activity, the move to Nu-2, made the object less unique from a resource allocation standpoint. If it behaved mostly like a local comet, the argument for diverting vast resources to intercept it weakened considerably. The change to the archival data can be viewed through the lens of institutional conservatism, a quiet, pragmatic decision to manage expectations and resources by minimizing the perceived scientific urgency of the target. It is the astronomical equivalent of deciding that the anomaly is a false alarm. But what if the initial calculation, Nu-1, was the correct one? What if the object truly was shedding volatile gases at an extraordinary rate, suggesting a highly unique origin? The difficulty of accurately measuring non-gravitational forces is the scientific alibi. The measurement is incredibly sensitive to the exact model used for the solar heating and the physical characteristics of the comet's nucleus. It is easy for a scientist to argue that their reanalysis, using a more sophisticated or slightly different model, yielded the lower number, Nu-2. This plausible deniability is precisely what allows a silent revision to occur, without immediate, widespread controversy. This leads us to a fascinating philosophical point. The planet doesn't keep a diary. The comet, 3I Atlas, simply moved through space, shedding its tiny, volatile jets in accordance with the laws of physics that govern its structure. It does not care which number Nu-1 or Nu-2 humanity assigns to its behavior. The data is a snapshot of an objective reality, but the interpretation is a product of human minds, human budgets, and human desires for either continuity or discovery. The mythic connection here is to the figure of Cassandra, the Greek prophetess, whose true warnings were never believed. The initial, high-activity warning of Nu 1 was, perhaps, the Cassandra data point, quietly dismissed in favor of the more comforting, less expensive prediction of Nu 2. We will now zoom out, pulling our attention away from the subtle digital alteration to the cosmic perspective of interstellar travel itself. What does it mean for our small, wet planet that these travelers, our cosmic heralds, are now being routinely detected? How many of them have we missed in the centuries before Atlas and the other sky surveys began their tireless watch? To understand the weight of the altered data, we must first understand the incredible scale and frequency of interstellar travelers in the great, deep silence of the galaxy. To truly feel the quiet weight of the data alteration concerning 3I Atlas, we must look back only a few years, to the time before it, to the arrival of the first confirmed interstellar visitor. This was the original wanderer, an object whose name, when pronounced slowly, sounds like a whisper in the Hawaiian language, Oumuamua. Its discovery in the year 2017 was an astronomical shockwave, a moment of quiet, paradigm-shifting realization that the interstellar medium was indeed a vast, bustling thoroughfare, not the empty void we had once imagined. Oumuamua's story is the essential preamble to the mystery of 3I Atlas. The first wanderer was detected by the Pan-STARRS telescope in Hawaii, moving so fast that its trajectory was unequivocally hyperbolic, confirming its alien origin. But unlike a typical comet, Oumuamua did not initially display the expected tail, the glowing coma of gas and dust that signals a comet's volatile heart. It looked at first like a piece of rock, an asteroid. Yet, as it sped away from the sun, it exhibited a noticeable, unexplained non-gravitational acceleration, that subtle, mysterious kick we have been discussing, our invisible feather of Delta Nu. The mystery was, and remains, profound. The object was accelerating, meaning something was jetting gas to push it, but no gas was visibly detected. This led to a furious, sometimes contentious, debate within the scientific community. The prevailing and most conservative explanation was that it must have been jetting an invisible gas, perhaps pure water vapor, from beneath a thick, non-transpiring crust. The most speculative and frankly fascinating explanation was put forth by astronomers like Dr. Avi Loeb, suggesting that the non-gravitational push might be due to solar radiation pressure, acting on an extremely large, thin, naturally occurring light sail of some kind. This, of course, raised the quiet, unspoken possibility of an artificial origin. The sheer scientific tension surrounding Oumuamua was immense. It was an object that utterly defied categorization. It was accelerating like a comet, but looked like an asteroid. It was an anomaly that forced scientists to confront the limits of their current models. The intense, sometimes uncomfortable, scrutiny that Oumuamua received may hold the key to understanding the quiet handling of 3I Atlas. After the intense, protracted debate over Oumuamua, there was, perhaps, a collective institutional desire to avoid another such cosmic controversy. When 3I Atlas arrived in the year 2019, it was, by all initial appearances, a much more normal traveler. It developed a visible coma and a tail, clearly identifying itself as a comet, a standard refrigerator in space. The scientific community breathed a collective sigh of relief. Here, finally, was an interstellar object that fit neatly into an existing classification. However, The initial measurement of its non-gravitational acceleration, our new one, suggested a highly vigorous jetting, consistent with the supervolatiles we discussed earlier, the kind of exotic ices that point to a truly cold, pristine origin. It was, in its own way, just as special as Oumuamua, but in a chemical, rather than a geometric, sense. The echo of the first wanderer is this: the scientific establishment, and specifically the people in charge of data dissemination at institutions like the Jet Propulsion Laboratory, may have developed a preference for order over anomaly. The Oumuamua debate had been disruptive, controversial, and expensive in terms of scientific time and reputation. When 3I Atlas presented the initial data suggesting it, too, was an extreme outlier, a highly volatile, deeply exotic object, the subtle pressure to make it fit a less challenging, more conventional model may have been the quiet motivator for the silent revision. This is the philosophical hinge on which our entire story turns. The conflict between the curiosity of the explorer and the caution of the custodian. The explorer wants the high-jetting new one data because it promises a revolutionary finding about the interstellar medium. The custodian, responsible for the stability of scientific understanding and the allocation of finite resources, prefers the lower, more conventional Nu-2 data because it maintains the existing, comfortable paradigm. The silent revision is the custodian's quiet victory. The sheer difficulty in measuring the invisible feather of Delta Nu provides the perfect cover. The non-gravitational force is measured by calculating the difference between the actual observed path and the path predicted by gravity alone. The process involves a multi-parameter, fit an incredibly complex calculation involving the comet's rotation, the orientation of its poles, the exact physical model of its nucleus, and how the sun's energy is absorbed. A subtle and entirely justifiable change in any one of these many parameters can result in a change in the final non-gravitational figure. A scientist can honestly claim that their new, more refined model simply yielded a lower number. The issue is not the new calculation itself, but the lack of an accompanying public announcement that the historical, archived record was being updated and that the previous, higher value was being effectively expunged from the readily available, official dataset. This quiet, administrative maneuver has a clear mythic resonance. It is the tale of Procrustes, the legendary figure who forced his guests to fit his bed, stretching them if they were too short, or lopping off their legs if they were too tall. In the case of 3I Atlas, the initial, highly active data point, Nu-1, was too long for the established Procrustean bed of a normal comet, and so it was quietly trimmed to fit the acceptable length of Nu-2. Where are you listening from tonight? Take a moment to feel the immensity of the silence that has passed between the arrival of the first wanderer and our current time. It is a silence filled with these invisible travelers. We will now turn our attention to the physical consequence of this data change, the subtle shift in our understanding of what 3I Atlas was chemically made of, a shift that takes us from exotic ice to something far more terrestrial. Let us now broaden our gaze, moving from the tiny, invisible feather of non-gravitational acceleration to the profound, existential scale of the Great Silence. This is the term given to the quiet paradox at the heart of the search for extraterrestrial intelligence, or SETI. Given the immense number of stars and the billions of years available for life to evolve, where is everyone? Why do our most sensitive radio telescopes listen to a universe that is so profoundly, so unnervingly quiet? The mystery of the Great Silence is often explained through concepts like the Fermi paradox, the idea that the lack of observed civilization suggests some kind of universal filter or bottleneck, prevents life from reaching a highly advanced interstellar stage. Tonight, however, we will explore a more humbling possibility, that the filter is not in the universe, but in us. Our own institutional and psychological biases, the same forces that quietly normalize the data of 3I Atlas, may be acting as a silent SETI filter. The challenge in the search for extraterrestrial intelligence is precisely the problem we have been tracking with the interstellar comets, the expectation of the ordinary. We search for signals that are easily recognizable as artificial narrowband radio waves, repeating pulses, patterns that look like our own television or radar signals. We are, essentially, looking for a radio transmission that sounds like a slightly older, slightly stronger version of a signal we ourselves would send. We are, in short, looking for our own reflection. But what if a truly advanced civilization communicates or signals its presence in a way that is utterly alien to our current physics or technological capacity? What if a truly advanced signal is not a noisy radio blast, but an unexplained anomaly in a massive data set that we, due to our deep-seated preference for order over chaos, quietly discard as a measurement error or a natural phenomenon? The case of Oumuamua, the first interstellar visitor, is a direct case in point. Its unexplained non-gravitational acceleration led to the controversial suggestion that it might be an artificially crafted light sail. This hypothesis, while fascinating, was met with deep skepticism and, in some cases, outright ridicule from the mainstream scientific community. The quiet, institutional preference was to explain the acceleration through a natural process, however unlikely, like the venting of invisible hydrogen gas, rather than embracing the anomaly as a potential technological signature. The quiet alteration of the 3I Atlas data, the shift from the highly volatile, truly alien Nu 1 to the more conventional Nu 2, is the same psychological process writ small. It is the system exhibiting a powerful drive to contain the unusual. If an object appears that defies our models, the human instinct is to adjust the measurement to fit the model, rather than adjusting the model to fit the measurement. This instinct, when applied to the search for intelligence, becomes a potent filter. Imagine a data stream that shows a subtle, non-natural variation in the heat signature of a distant planet, a signature that could be interpreted as an immense, Dyson, sphere-like structure, a mythological construction built to capture a star's energy. The initial, high anomaly reading is posted. The scientific team, fearing the Oumuamua controversy or the budgetary risk of a speculative follow-up, quietly reanalyzes the data using a more conservative model of stellar flare activity. The anomaly vanishes. The great silence is preserved, not because no one is out there, but because the evidence of their presence was normalized out of existence in the archive. This mythic echo is of the Emperor's new clothes. We are so invested in the comforting, established narrative, the idea that the universe is quiet and that we are at the center of the story, that when a tiny, anomalous data point suggests otherwise, we are systemically conditioned to ignore it, or worse, quietly edit it until it fits the pre-approved narrative. The Jet Propulsion Laboratory is not a malicious entity, but a highly effective bureaucratic machine designed to deliver predictable results. Predictability, however, is the enemy of revolutionary discovery. Where are you listening from tonight? Consider the quiet irony. The sheer scale of the universe demands humility and open-mindedness. Yet the human institutions we build to study it are inevitably prone to caution and conservatism. The silent SETI filter is the collective result of thousands of small, justifiable decisions to prioritize order over anomaly. We will now gently move from the existential quiet of the great silence back to the cold, hard realities of Earth's weather. We will explore a brief, fascinating reflection on how the subtle power of non-gravitational forces, the same volatile push that was edited out of 3I Atlas, is also the primary engine of some of the most dramatic weather phenomena on our own planet. This will give us a sensory, terrestrial feeling for the subtle power of the invisible forces at work in the cosmos. Let us now sit quietly with the ultimate consequence of the silent revision, the blind spot of normalization. If, when presented with a truly unique or extreme piece of data, the system's quiet response is to adjust the archive to fit a pre-existing, less controversial model, then we risk developing a deep, institutional short-sightedness. The subtle trimming of 3I Atlas from the highly volatile Nu 1 to the less demanding Nu 2 creates a paradigm of passivity that extends far beyond a single comet. The core function of the scientific method is to test the limits of our understanding, to look for the data that breaks the existing model. When a scientist encounters an extreme outlier, a velocity far too high, an activity level far too great, a light curve too strangely shaped, that outlier is a flashing arrow pointing toward a new physical law, a new type of object, or even an entirely new process. It is in the anomalies that the cosmos whispers its secrets. But the act of normalization, the quiet editing of the archive to bring the object into a more standard category, teaches the institution and the broader scientific community a dangerous lesson: don't trust the outlier. It suggests that if an observation seems too strange, the error is likely in the observation or the calculation, rather than in our understanding of the universe. This creates a blind spot, a psychological and procedural failure to recognize the truly unprecedented when it appears again. Imagine a future scenario, a few years from now, when the Vera Rubin Observatory comes online, an immense, wide-field camera that will revolutionize our ability to detect faint, moving objects. It will undoubtedly discover dozens, if not hundreds, of new interstellar travelers. If the established, archived precedent is that any initial high volatility reading is subsequently trimmed to fit the water ice model, then any future object that truly is rich in exotic supervolatiles, perhaps a pristine piece of a frozen, extrasolar planetesimal, will be automatically subjected to the same normalization bias. The truly revolutionary discovery will be quietly filed away as a slight measurement error. This is the great, quiet tragedy of the 3I Atlas revision. It is not the loss of a single data point, but the subtle corruption of the institutional gaze. It affects the filters we apply to the universe. We stop looking for the truly alien and start only seeing versions of ourselves reflected back in the cosmos, objects that behave according to the established rules of our own solar system. The universe is far more imaginative than any grant proposal, and by imposing our expected order on the interstellar visitors, we lose access to that magnificent, chaotic imagination. Let us return to the three anomalies that anchor our story and connect them to this new blind spot of normalization. The volatility discrepancy, the difference between the high Nu 1 and the low Nu 2, demonstrates the ability of the system to self-correct toward the expected mean, rather than embracing the unexpected extreme. The non-announcement, the lack of transparent justification for the change, teaches the next generation of scientists that data changes can happen in the archive, undermining the trust in the permanent record of observation. And the target downgrade, the reduced urgency for a dedicated mission, sends a message that exotic discovery is less important than budgetary stability. The mythic reflection here is the story of the mapmaker's fear. In ancient times, mapmakers would often write, "Here be dragons," on the edges of their known world, not because they knew dragons were there, but because they feared the unknown. The quiet revision of the 3i Atlas data is the modern-day equivalent of the astronomer or the data custodian, quietly rubbing out the "Here be exotic ices" annotation and replacing it with the comforting label, "Standard Water Comet." The fear of the unknown is quietly replaced with the illusion of certainty. This silent act of normalization is deeply rooted in the human reflection we discussed earlier. It is a desire for peace inside the scale of the cosmos. The universe is immense, indifferent, and chaotic. To maintain our sanity and our scientific focus, we try to contain its chaos in beautiful, predictive equations. The data point of nu-1 was a challenge to the equation. The quiet insertion of nu-2 restored the balance, but at the cost of genuine inquiry. As you listen, wherever you are tonight, feel the subtle tension between these two forces, the terrifying vastness of the universe and the small, human desire to categorize and control it. We are about to pivot away from the specifics of 3i Atlas and look at a grander scale, the great silence itself. We will ask if this kind of subtle, systemic normalization could be influencing not only our search for interstellar debris, but our far grander search for extraterrestrial intelligence, the quiet, profound, and deeply human question of whether we are truly alone. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3i Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3i Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase, every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3. I-Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars. A nowhere place. A mathematical shrug. That's when someone joked, maybe it's the universe's typo. But you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing. gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice, numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, It wasn't random. It was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy. But the laughter is short-lived, because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges, faint, angular, deliberate, a hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3i Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3i Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new. Faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together. A self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation's subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response. The universe just said thank you." After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the web's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the web's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the web, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, Another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas web pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the web. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas web had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice, each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, It's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time, and somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. The burden of the 20-year secret watch, the knowledge of the quiet seeding, and the 477-year census cycle is too immense and too critical for the human spirit to carry indefinitely in silence. Therefore, the strategic final phase, after 3, I-Atlas had departed and the Deep Archive protocol was underway, involved the deliberate, subtle release of information, the information trickle. This was a carefully orchestrated, slow introduction of the underlying truth into the public domain, preparing the collective human mind for the inevitable, quiet reality of our cosmic dependency. Imagine the psychological strategy. You cannot tell the world. An alien probe visited, gave us the blueprint for our next 3 technological revolutions, and is coming back in 4 centuries. This would lead to panic, political instability, and the collapse of scientific credibility. Instead, the truth must be filtered through academic curiosity, controlled leaks, and the quiet, persistent work of a few authorized voices. Anomaly number 1, the Academic Whisper Network. Shortly after 2020, a small, hand-picked group of non-governmental scientists, astrophysicists, and experts in materials science were quietly given access to controlled fragments of the 3 I-Atlas data. This data was heavily sanitized, framed as observations of the object's peculiar, natural anomalies, the high density, the ghost trajectory, the unusual lack of outgassing. The purpose was to encourage independent academic research that would, through entirely terrestrial means, arrive at the same conclusions as the secret observers. Dr. Avi Loeb, with his calm insistence on the possibility of a technological origin for interstellar objects, serves as a prominent, authorized voice in this trickle, planting the seed of the technological hypothesis in the public sphere, framed not as a state secret, but as provocative scientific speculation. Anomaly number 2, the disclosure of precedent. The concept of the Tunguska event as a potential technological failure, which had been confined to fringe theories, began to receive quiet, subtle validation through the gradual declassification of peripheral atmospheric data from the 1980s and 90s. The quiet, official release of data confirming the high-altitude nature and the non-fragmentary nature of the explosion provided a crucial, historical precedent cue. This gently nudged historians and scientists toward the possibility that interstellar arrivals are not always natural, and that our past has already been influenced by non-terrestrial objects. This acts as a slow-motion inoculation against the shock of future. Full disclosure. Anomaly number 3, the media resonance. The secret observers understood the power of myth, metaphor, and media resonance. Over the years following the probe's departure, there was a quiet, almost imperceptible shift in popular science and entertainment toward the themes of quiet, non-aggressive, algorithmic, alien contact. Films, books, and documentaries began to explore concepts of long-duration autonomous probes, silent gravitational archives, and subtle technological seeding, often incorporating exact numbers and patterns like the 7-fold modulation or the 477-year cycle that directly mirrored the classified data. This is a form of cultural desensitization, using the gentle rhythm of storytelling to familiarize the public mind with the profound and unsettling quietude of true, ancient contact. The dry, subtle humor in this information trickle is that the public is slowly being prepared for the most profound truth in human history through academic papers and science fiction movies. The secret observers are not lying. They are simply editing the introduction, ensuring that the human spirit is not shattered by the immensity of the truth, but gently eased into it over decades. This is an act of responsible statecraft, managing the psychological consequences of the universe's great silence. The ultimate goal of the information trickle is to ensure that when the next probe, 3-2 Atlas, arrives in the year 2697, the human civilization of that era will have a cultural memory and a scientific framework that allows them to access the deep archive and calmly acknowledge the visitor, continuing the stable, sustainable relationship with Star System X. We now turn to the final thoughts, the gentle closure that honors the immense journey we have taken from the quiet terror of the 20-year watch to the serene acceptance of our role as a subject of the galactic census. The final segment will focus on the quiet closure, the final, existential thought that brings us back to the soft peace of sleep. The journey continues, always gently, into the quiet, closing reflection.